So, good morning, everybody. Welcome to this presentation. We're going to talk about Ext today. I'm Per Minborg, and I'm CTO of Speedment.
And I'm Jon Jarboe with Sencha.
And we also have Anson here from Ext IO, sitting right in front here. He's going to do a featured show in this presentation. So, we're going to talk about Ext JS and Ext. What is it? Ext has mainly two good things, and one thing is to make the development much faster. And the other one is how to improve your performance, how to make the execution faster. And that's the focus of this presentation. So first of all, before we start, I'm going to give you a little heads up about other presentations. There's a presentation today at 2 a.m. That is also about Ext, and it's with Olga Petrova. She's sitting right here. Yeah, so make sure you catch her presentation. And there's another one that's focused more on ease of use, how to be productive and how to quickly generate your backend. Later today, that's Emil and myself, just as in this location right here. So let's talk about Ext. And yeah, John, I'll leave it to you.
Sure, thank you. So when we're talking about Ext, I guess it's just to give you a real high-level picture of what's going on. Is typically you'll have your Sencha application, and it's talking to some sort of a data backend. And Ext really just kind of sits in between your application and the data backend, and its purpose is to help accelerate the accessibility of the data that your application is reaching. And of course, as Per mentioned, we're going to be going into more detail about that as we go through the presentation. Kind of at the very beginning of the process, you're going to be using Ext, and you're going to have to set things up, and we provided a backend, or rather we provide a tool to help create that backend so that it's providing the data that you're interested in exposing through your application or through other applications which may be using that same backend. And it's really going to help simplify not only how your application uses that data, but the creation of that backend so that it really is accessible even to front-end developers who may not be familiar with backend work. And of course, as Ext developers, you're familiar with how easy it is to design, develop, and deploy your application through standard means, and it's just as easy when you're using Ext. And in terms of the backend, the Ext tool actually creates that backend and provides you with all the source code that it uses to create that backend. And since that code is all generated automatically, you don't need to worry about maintaining it or testing it for bugs, that kind of thing. It's all been taken care of through the code generator. And at the end of the day, once you have the application built and deployed, you're going to be leveraging the Speedment in-memory technology to really accelerate the accessibility of that data from your application. It depends on the application and the data itself, but typically you'll be finding something like a 10x improvement or even greater in the accessibility of the data from your application. I'm not going to spend too much time on this slide because I assume you're all Ext users, but in general, Ext, of course, provides a very feature-rich and data-intensive, tools to help you build data-intensive applications that are going to be running through web technologies, whether it's mobile or desktop or some other type of web-accessible technology. Now I'd like to talk a little bit more about specifically how this works. This is just showing you kind of what a typical Ext application looks like. You have the front end running on the client, probably based in Ext, and obviously you have a bunch of UI components, and you probably have some sort of local data which is running within the browser, and then you have a data manager which helps pull data in from other sources, whether that's a server that you control, public sources, doesn't really matter. The data manager kind of pulls all of that together for you. And on the server, where you're pulling the data from, you'll typically have some sort of a web application, a backend that's running there. You have a server that's serving up static pages and assets, that type of thing. And then you have data services which have been built by your backend team, or in shops where you have full stack developers. Perhaps the same people are working on the backend as the front end. But in general, those data services are being built manually, and they might be exposing data through a REST API or some sort of SOAP or web services type interface. And then ultimately, those data services go to the backend. And in terms of building that traditional backend, those data services that expose your data, there are a lot of some of them are small steps, some of them are big steps, but there are a lot of steps that need to be taken into account as you're building that data backend. And at the end of the day, when you build that backend, you're typically looking at something like 24 developer hours to actually build all of that, test it, understand the structure of the data, and kind of incorporate all of that into the web services. And remember that number of 24 hours, because in a little bit I'm going to be talking about Ext, and I'll compare the effort taken to develop something in Ext with what it takes through a traditional backend. And speaking of Ext, I just want to talk a little bit about kind of what the architecture looks like with Ext, even if you're not using an Ext JS front end. You'll have some sort of a client, whether it's a traditional application or whatever. It doesn't have to be Ext JS, doesn't matter. But the server itself, of course, you still have your web services, and you still have the data services that you've been building. And Ext just kind of sits on that same server under the covers. And I mentioned that there are kind of two parts to Ext. There's the tool, which helps you build the backend, and then there's the backend application itself, which runs on the server. In this image, they're kind of consolidated a little bit, but typically the tool which builds the application is run during the development phase and is not part of the deployed application. But that tool, which helps you build the backend, actually introspects onto the database server which you specify. So you already have data sitting in your backend, and the Ext tool is able to kind of look at that, understand where all the tables are, all the fields, what the relationships between all of those tables and things are, and it helps you build a complete REST API that exposes all of the information in the database. The tool itself actually has a nice GUI that helps you easily select what you want to expose. You don't have to expose everything that's in the database. By default, it's all accessible, and then you just check a few boxes to tell it whether you want to have, well, if there's private information or something that you don't want to expose, you can kind of hide that through the GUI. But at the end of the day, you've built this complete REST API that exposes the information that you want from the database. And in terms of what's actually running on the server, you have this in-memory object store, which pulls in the entire contents of your database, and it understands, as I mentioned before, the various tables that are there, the columns that are there, the relationships between the tables, and it really pulls all of that into memory, builds a sophisticated kind of structure around it so that when you're requesting data from the server, it's able to not only provide the information that you requested, but do so extremely quickly because it understands everything that's in there, and it doesn't need to keep going to the back end to pull in additional pages of results or anything. It does all of that up front. And then when you kind of pair that together with the Ext JS application, as we talked about before, the data manager helps you access that remote information. And instead of talking to manually developed data services within your backend application, it's actually talking to the REST API, which was built by Ext, and using that in-memory object store to quickly provide the information to you. And the really nice thing is it uses all of the standard Ext JS interfaces, so you don't need to make any changes to your application except to tell it to get information from a different source. And then you can immediately leverage all of that, all of those speed improvements simply by nature of the data coming back to your application more quickly. And you may remember the earlier slide where we talked about what it takes to develop the back-end application and the data services through a traditional means. When you're working with Xpeeder, it's actually quite a bit faster. And the number of steps that are required are quite a bit lower because a lot of that has been automated through the introspection process. And at the end of the day, in order to build this complete REST API, you're looking at more like an hour instead of the 24 developer hours, which it takes for the traditional back-end development.
Yeah.
And with this, I guess I'll hand it back to Per, who's going to go into a little more detail about specifically what's happening within the Xpeeder application.
Thank you. Mm-hmm. Yeah, so this is how Xpeeder looks like. This is the introspected database with all its columns and tables. And at the right-hand side, you can select things here. You can maybe deploy this at another REST API endpoint, or you can select if you want to expose this at all. You can disable columns or tables or whatever. And when you're finished, you just push this button, generate over here, and then you get all your application packed and ready to be used. So it's automatically REST API. It's an in-memory technology, and you can deploy this in a Java EE server, because everything that's generated is Java. But, well, if you're working with Java today, that's good news. But if you don't work with Java, it doesn't matter so much, because usually you don't have to do anything with the code. You can just deploy it in a standard server. Most of these servers has a drag-and-drop interface, so you can just take what's generated and just drop it into the application server. So this is the process. When you first launch the tool, of course, you have to tell Xpeeder where your database is. So you can select the database type, IP address, and login credentials, and the schema you want to use. And then you just press connect. And then you get this kind of thing I showed in the previous slide here. So it's very easy to access your metadata. And then you just use it. In this example, it's just a browser. I think I should just show you how this works for real. So let me just challenge the demo gods here. Yeah, this first step. So here is a project I call the demo project. So, and Xpeeder is really just a plugin to your development tool, so you don't have to install anything on the computer. You just snap in a few lines of code in your project definition, and then these targets are automatically appearing here. So there is something here called Xpeeder tool. I just double-click that, and then it starts. Now, this is not the first time I started this, so the screen where you enter the IP address of the database is not here. But you can see here that you have the entire structure here on the left-hand side. This is kind of a tree. So, for instance, I have a bunch of countries here. This is a sales info database with salespersons, articles, pricing, and everything. And there is specifically a table with all the countries, so maybe here I can decide if I want to enable this or not. I can shoot whatever REST path I want here and put in whatever I want here, and I can name this. It is named country, but I can name it whatever I want. And this is true also for columns. Maybe there's a password column or some other sensitive piece of information here, and you can just click that and you can disable that, and it will not be exposed in the REST API. So it's very simple. It's a very simple tool. So you don't need to know anything about programming, really, to use this tool. And I just press generate here, and wow, everything is generated for me. So now I have a complete application. So I can run it. It's running here right now. So let's switch back to the browser. Well, here's the REST API, so I just, call that, and I will have a REST representation of, in this case, it's the countries. I have Andorra and other obscure countries, and it just goes on like this. And as you might see, it's very quick, so since it retrieves everything from in-memory stores, it's just like a matter of milliseconds. And it doesn't matter how big the table is. This is just a small table because the number of countries is like 200 or something. But if you can have like 100 million rows, and you will get almost the same response time anyhow. So let's go back. Yeah, let's talk a little bit about the acceleration. How is this possible? How can it be that quick? Yeah, as John said, we pull in everything in memory. And this is done when you start the application first, but it's also done on regular intervals. And you can configure that interval. So maybe for some applications like analytics, it's enough to refresh your data set maybe in the evening or at night. Whereas in other applications, you might do it for each hour or each minute or whatever you select here. And everything is seamless. This is nothing, you don't have to bother about this. This is all happening in the background. And there's a multi-version and concurrent control, so you can have one set that you're working on, and while you're populating a new set in the background completely automatically, and when that set is ready, it just switches into the newer threads, and when all the old threads are done, that old version will be discarded, and you will have the new one working. So you will always have a consistent view of your database state. You can deploy this in a number of scenarios or back-end architectures. First of all, you can just run it as a standalone Java application. And that's good for testing, like in my computer right away. In my development tool, I just run the application. But in an enterprise environment, it's likely that you want to use a more advanced server, so you can use a Java EE server, like Oracle WebLogic, Tom EE, Pariah, JBoss, or Jetty, or any open source version that you prefer. And there's a bunch of other web servers here too. So I think there are like 100 different Java EE servers. So. And we also support all the major IDEs for Java development. Those are the 3 big ones. And it's just a plugin, Maven plugin, so therefore it will fit all of them. We support all the big open source databases and Oracle out of the box, and we support every other type of database in projects that we do together with customers. When it comes to Ext JS, we support all the recent, maybe JS4 is not recent, it's a long time ago, but we still support Java Ext JS 4, and you use an ordinary buffered store, whereas for an Ext JS 4 you use a regular store, but you have to set this parameter buffered equals true. So it's very easy to integrate with Ext JS. Well, specifically, how is the acceleration done? I mean, pulling everything in memory is good, but it doesn't necessarily make things quick. So we have a number of features to really be able to provide your result sets really quickly. First of all, we pull in everything in memory, and you might ask, is that really possible to fit that into memory? And yes, most of the time it is, because today you can get a server with a very large amount of RAM. We provide sorted views with every column. So if you have a grid, for example, and there's already a prepared sorted view for all those columns. So it doesn't matter on which column you click. They're already kind of pre-sorted. So you will have the exact same performance regardless of which column you sort on. We can do filtering. And the thing there is that we do an in-memory filtering optimization. So all of the filters that are supported can be retrieved basically in just one operation. So if you want to find all people named Bob, for example, that's just a single operation. So you will get that in typically like milliseconds time. You don't have to iterate over all the persons in that example. There's also a clever dictionary, because one of the most common ways of using a grid is that the user they have a long list, and then they scroll like this. On the right-hand side, there's a scroll bar. And if you have a normal database and you have 100 million records, and you scroll somewhere to the middle, well, then you have to wait like 10 to 20 seconds in a normal case. But using these lookup dictionaries, you only have to wait like a few milliseconds. So you can just scroll around in a very big data set, and there's no getting slower, regardless if in the beginning, in the middle, or in the end, or just before the end. It's the same performance. And also we cache the totals, because as Ext JS works, it needs to know that it's showing, I might show between 100 and 200, but it needs to know how many records there are in total that fits for that kind of filtering. Or So we cache all of them, so we will also get good performance for that type of element in the response. So now that was theory. Now it's more like demo. So we took an open database with all US doctors. This is just any type of database, nothing specific. Specific. And it had 40 million objects. And we compare that with a normal database, in this case a MySQL database. And for scrolling through that massive amount of objects, it took 3 seconds with a database, whereas for Expeditor, it took like less than 200 milliseconds. And well, if you are below like 600 or 700 milliseconds, you don't notice that so much. But if you go over 1 second, it's slow. For sorting, it was 3 seconds, but just about half a second here for the Expeditor. And for filtering, it was much longer, like 9 seconds, but just 200 milliseconds, or 300 for Expeditor. So that's a 28 times speed up, 7 times speed up, and a 38 times speed up. I know, okay, 28 is good, but the really good thing is that you go from above 1 second to less than 1 second. I think that's the most important thing, because if it's 100 times quicker or 28 times quicker, it's not so important. But the important thing is for the user experience that you are coming down to like a half a second or 1 second, and that's the thing you can do with Expeditor. So let me show you a demo of that, a real execution, but on a video. So it's semi-real. Okay, so.
We have built an open database with doctors in the USA containing 40 million objects. We will scroll, sort, and filter in this dataset. Let's compare the common way versus the Ext speeder way. On the top, you will see the common way, and in the bottom, the Ext speeder way. We will sort, scroll, and the grid.
So you see the difference here.
Now, we will sort the grid by last name. And finally, we will filter the grid for organizations ending with .h. As you can see, each speeder is 28, 7, and 36 times faster. Thank you for watching.
So it's really a big difference in terms of interactivity. So John, now it's time for your demo.
Okay.
So maybe we should.
Yes, I'll switch. Thanks, Per. How much time do we have?
Maybe it's.
Okay. Yeah. There we go. Okay, so I will try to keep this somewhat short because I know Anselm's coming up and his demo is going to be a lot more interesting. This is really more designed to help you understand some of the basics of how the pieces fit together. In this case, what I have is an application that, as you can see up in the upper right here, has almost 700,000 records in it. And we're looking at a pivot table. And basically, I just have a little switch here that lets me switch between traditional or Expeditor in terms of how it's accessing the back end. The rest of the application is exactly the same. And one of the challenges with a pivot grid is that you don't always know how the user is going to be interacting with the data. If they're going to be sorting by different fields, or if they're going to be filtering or excluding certain fields, you don't necessarily know that in advance. And so it's very hard to prepare the back end to handle all the various use cases that users are going to come up with. As a developer, I'm sure you understand that users often come up with creative ways to use the application that you never thought of. So in this case, we have, well, I'll start with the traditional backend. And with the traditional backend, if I just refresh the page so that you see kind of what the loading experience is like, it takes a little bit of time and ultimately comes up with a pivot grid that includes the, the various fields. In this case, we have it we have the salesperson and the product along the left axis, and along the top we have the countries. But maybe I don't really care about the country so much. If I wanted to, maybe I'm more interested in the office. So I can just take the office, drag it down here, and each time that I make a change, you can see it's accessing the back end and trying to update the grid. And since I don't really care about the country, I'll remove that. And up here in the top, you can see that the traditional case is taking about 5 seconds for each update. It was actually a little bit longer for the earlier ones, but now we're down to 5 because there are a lot of empty fields in here. And if you've worked with the pivot grid before, you know that there's a lot more going on behind the scenes than you see in the view here, simply because when you're looking at this, it's actually an aggregation of what's going on. So for Ankita, you'll see a number of different rows here corresponding to how much sales she had out of this particular office for each of the various products. And so with each of those being about 5 to 8 seconds, if we switch over to the XSpeeder backend, you can see that we're already under a second, which is almost a 600% improvement, or a 6x improvement for this. And with each of these operations, if we want to do it by product, maybe along the top axis, and maybe we'll move Office over here to the left axis. Each of these, as you can see, each time that we make a change, now we're down under a second, a little more than 3/4 of a second for each of these operations that we're doing, which just kind of shows you the types of improvements that you can find by using XSpeeder. I'm not going to spend any more time on this because I want to allow Anselm to come up and do his more comprehensive demo, I guess. Visually, his has a lot more things going on simply because that's more realistic in terms of the types of applications you guys are probably building. This was very simple just because I wanted to kind of explain what you can expect from a specific pivot grid instance.
All right, great.
Go back.
Hi, my name's Ansel McLean, and I work for Extremely Heavy Industries, or XHIO. And we've been building Ext JS apps for a number of years, specifically in the worlds of finance and trading. And it's an area where you end up with a lot of data. You spoke about kind of data-intensive applications, which is absolutely where we're at. And we've relied on Ext because we know on the client side it can handle data-intensive applications, including big grids, visualizations. But it's also really important to have a backend that can keep up with it. And so we put together a demo, kind of have partnered with the Speeder team to understand how their technologies work, and they really play well with the kind of apps we like to develop. We put together this demo. This is basically what you're looking at here is an app that's on top of a database, about 1.5 million rows of performance data, daily performance data on a position level for a synthetic portfolio. And with the Speeder team, there's a number of other interrelated linked sources of data. And these kinds of apps, what we like to do is have mashups where you basically have a central aggregation. You need to be able to quickly slice and dice along a number of different dimensions, interact with it, and then for any given selection, you want to look at related objects. You want to look at what orders comprise this position. You want to look at a given instrument and quickly load prices. And you want to be able to do this all very quickly because you're some sort of impatient trader. What we have here basically is an app that has 2 backends, actually. I did my best to produce a realistic backend implemented in a Java server without the Speeder technology, and tried to basically make it feature complete. That supports the aggregations that this app demands of it, as well as kind of the paging and buffering that the various grids in the app want to do. And then we also have an alternate backend that I put together with the Speeder team. And we did this all over the course of, I don't know, about 5 days or so. And we were able to go back and forth very fluidly with them. They were able to, although their out-of-the-box product at this point doesn't support this kind of aggregation view, it's on their roadmap, and it played very nicely with the technologies that they have built. And as you'll see, there's also kind of a lot of just straight up out-of-the-box usages of the Speeder technology on top of our database tables. As per the pivot grid demo, we'll kind of first bring this up in non-Speeder mode and can look at the general performance there. We have a Ext tree grid coupled with a D3 visualization, and we can expand this. We can expand any given node in the tree, and it'll go ahead and go back to the server and request that node to be expanded and pull in child nodes. And this is kind of very classic sort of grid map interaction. You want to be able to quickly drill in something. I see that this model had some outsized performance. I want to understand what comprised that, what sort of sectors, and continue kind of drilling in to do that. You'll see in the bottom, as we go and make a query, we're loading a couple of different linked sources of data. We have a time series chart here that's going to show you how that performance accumulated over time. We're loading a grid of the orders that comprised all the performance within that slice of the portfolio and related prices. I did my best with this backend, and it's not bad to work with, I don't think, but you're certainly kind of sitting there waiting, and if you want to quickly kind of skip around this grid and really explore it and really dive in to a number of aspects of this performance, you're going to be waiting on that. So what we can do here is we'll enable our speeder mode, and we can refresh this. This is the same general view, and it refreshes pretty much instantly. So we see we've got that kind of under a second benchmark. We were at an average of about 3 seconds per call for a more traditional backend going against the database, as well as some in-memory work on the server. And now, calling the Speeder API, we're able to get the same request in well under a second. At this point, I think I can interact much more fluidly with this grid, and I can move through it. I can expand nodes. I can also use the keyboard here, which is important to us. So I'm able to zip through these different rows. And each time I'm going to a different aggregation, this client is going to go. It's going to load a daily time series of all that. This is hundreds of thousands of records underneath the cover are being brought together, queried, filtered, aggregated, and then sent out to this client. We can do a couple of more classic kind of examples of the buffered grid. I can right-click here. I can grab a given slice of this portfolio, and I can look at all of the underlying data. So that just pulled up about 100,000 records that represent that slice of this portfolio over time. This is a very traditional Ext buffered grid. So this is very vanilla grid here in this pop-up window with a simple buffered store pointing at just out-of-the-box Ext speeder endpoint. And you'll see the kind of scrolling performance, the kind of buffered grid, endless scrolling performance that you really want when you talk about putting big data in a grid. You're not looking at the, oh, my grid works well with 200 rows or 300 rows. You're really actually, no, I actually need a grid that's going to work well with hundreds of thousands of rows and support the kind of filtering and quick slicing and dicing that they mentioned in their video. Without these kinds of interactions, you really, I think, are limited in how much data complexity you can put in an app. And I think that it's something that people don't often really get to see is exactly what you can do with an Ext JS app and exactly how much data it can really manage and how much information you can convey in a space like this. But you really sort of need the combination of the front-end client-side tools and visualizations that will work with it, as well as a back-end that can support it and is well-written and is capable of actually delivering the performance that you're looking for. Just a couple of other, again, you can pop up a price chart. It'll load that. This is going to load an entire multi-year series of open, high, low, close prices for a given security. There's a lot of data in this. So each one of these is going to be 4 data points. And you're looking over the course back to 2010 or something like that. It's a lot of information. It's able to come up in the UI very fast. And we're able to kind of convey this is exactly what our kind of clients need to be able to see day in, day out on a variety of different levels. The aggregations, I think, are really important. And I think that's something that the Speeder team really understands. It's something that's really key to us. And a lot of data that we work with, again, starts at a very low level, but it's really about giving users the ability to aggregate it the way they want. We're, in our practice, going to be looking more at the pivot grid and understand how that can work into our tool chain. This is, again, a tree grid, but we can still choose different aggregations. So I can switch to view this, say, by office, or I can say, no, I actually want to start at the sector level and let me look by sector. And then from sector, I want to drill into individual traders and see how they perform. I can go ahead and say, all right, well, who's trading consumer goods here and what does their performance look like, and expand that. It's going to immediately open. I can see this trader had some amount of performance and where's that being driven, what did he trade, what price did he get in or out at. We have some date controls here, so we can go ahead and, I love using these kinds of controls like sliders and things like that. I think it's a great fun way let people kind of interact with the data, quickly change queries without kind of putting together a tiresome form and submitting it and then waiting for a result. But again, as you're flipping through dates and have a control like this X slider here that's issuing queries to the server, you really need something, again, that can keep up. It gets a lot less fun to have kind of cool, fun drag and drop controls when suddenly the client falls down, either on the client side or the server side. One thing that was cool that I've wanted to kind of play with for a while is when you have the ability to pump data into an app like this, you can start to do visualizations that really kind of give you like a real-time or a playback view. So we have another tab here that we can take a look at. What this will do is it'll take all of the performance for this big portfolio, those 1.5 million rows, and it'll chunk it into the client as kind of a day-by-day or actually a week-by-week time series. So we can go ahead and hit play here. And the client's going to be loading this in. It's making, for each one of these, 4 or 5 different calls to the server. So each tick here is it's hitting the speeder endpoints, multiple endpoints. We're doing an Ext scatter plot visualization. We've got an Ext chart showing cumulative performance and orders over time, a D3 visualization showing breakout of order types and executions. And it's all going to be flowing into the client tick by tick with no real lag. That for us is really cool because it shows, I think, both the power of the SDK and what's possible with these kinds of apps. And I think it also really is a great demonstration that the speeder servers can keep up with the kinds of things that you might want to build really at the highest level. It's a lot of data as these little bubbles float around and bop back and forth, and the grid scrolls, the charts twitching, things are happening. But really, you have to kind of appreciate exactly how many different things are happening. So this is pumped at this point, 80,000 orders in here. And I think it's really fun then for business users, for people, and certainly for us as developers to be able to build apps like this that really can show off what the SDK can do, what we can do, and really be as data intensive as possible.
Yeah, so let's sum this up. It's good to have Xpeeder. You can use a data-driven applications. You can develop it faster. It integrates, it runs faster, and it's a seamless integration with Ext JS, grids, stuff like that. You get a much better improved user experience. As we saw with Anselm's demo here, you get instant response. And imagine if you would wait like 5 seconds for each click, that would not make it so fun. And it's also better if you want to maintain this application, because over time your database will change. And imagine all the manual stuff you have to do, but with this tool, you just connect again and you regenerate everything, and then you're up to date. So how do you get Xpeeder? Well, you go to xpeeder.com. You can download a free trial. And when you like it, you can buy a license. Like this, it's about the same model as Sencha. You pay a fee, and you can have up to 5 developers. And then if you want more than 5 developers, you can pay for that too. And there's a discount if you want to renew each year. We also do custom projects because we've been working with this now for quite some time, so we can help you out if you want special features, additional database connectors, for example. If you want to update your database, we can do that too in a clever way. Maybe you want to connect several databases. Maybe you have like 5 or 6 legacy databases, but you want to connect the information from all those databases and present an aggregate view in a quick way. That's something we can do. Maybe you want to scale out over several nodes. If you have even though Xpeeder is very quick, you might have a lot of users. We can do reactive WebSockets. We can do aggregating operators as we've done in this demo. So just contact sales, and we'll hook you up, solve your problems. So learn more here. www.xpeeder. Go to Sencha to learn more about Ext JS and xh.io if you want to have super cool applications. Yeah, and I encourage you to take the survey. If you like this, go into the app and say you like it, or if you didn't, say you didn't like it. Thank you. Thanks a lot for your time. So I think we open up for questions. How much time do we have? Yeah? Yeah, question there, yeah?
How's the REST API generation handling relational data?
Good question. Question was, how does it handle relational data? You see the columns as they are defined, but you can add something we call virtual columns that can take a foreign key and in 1 or 2 or 10 steps dereference that foreign key, so you can work with a completely normalized database, but still construct your views quite freely. So that's how it's done. And those virtual columns are first-class citizens, so they pull in and handle in memory just like any other columns. So you can sort and filter on them just as quick as any other column. More questions? Yes?
Does it support stored procs?
I beg your pardon?
Does it support stored procedures?
No, doesn't. And not in the shrink wrap product, but you can contact us in sales and we can fix that. But this is, you can use the database structure as it is, sorry. Yeah? It's Java, so you can't use it in .NET environment, but you can work, if you have a .NET sorry, environment, and you have like a huge backend to develop, but you have problem with maybe 1 or 2 REST calls, then you can run Xpeeder in parallel, so you can solve those performance problems with Xpeeder, but still remain your backend. Sorry, I'm getting a bit dry. So you don't have to, replace everything you had. You can just add Xpeeder on the side. So if there is something that is slow, like if you're satisfied with 99% of your REST calls, but there are 1 or 2 that are very slow, you can just do them with Xpeeder. Yeah?
How does inserting data impact the overall performance?
Sorry, how does? Inserting new data. Yeah, okay. So Xpeeder works like this. It takes a snapshot of the database, and that snapshot will be active until the next snapshot. So if you insert things, they will be seeing the next snapshot load, and you can set the time. So it's more like for analytics kind of applications. If you want real time, then you can disable the memory cache and you can work directly with the database, and then you still have the ease of use, but you don't get the performance increase. And then you can work directly with transactions. Yeah.
So what's the framework say?
Sorry?
If I need to set up a snapshot, what's the time difference between each snapshot?
That's a configurable time interval. You can set that in seconds. The default time is 1 hour, but you can have it much smaller time chunks if you want. But then again, it depends on how much data you have to load. If there is a small amount of data, you can easily afford to have a shorter time. But if you have a huge amount of data, then you don't want to reload each minute, for example. Yeah?
Support of Microsoft SQL Server?
Yeah, we can do that, but in a customer project. Yes?
Now I have my own RESTful application based on Java. Can I use like your application like a library external or you want to change my Java code?
I didn't hear that. I'm sorry. Yeah.
I have my own RESTful application based on Java.
Yeah.
Can I have your like library like import in my Java code?
Yeah. Yeah, can I use this in my Java? He already had Java code, and can I use Xpeeder in my application? Yeah, you can. There is a lot of code generated, and if you want to update that, override the behavior, you can do that. So you can change the code that's being generated. And you can still keep your old Java code doing the old stuff that the Java code did, and just replace those endpoints that you have problems with, for instance, with performance. Yes?
So in my case, I have multiple databases. Everyone is in so each database I have to connect different connection, or can I aggregate all of them in one connection?
Yeah, we can fix aggregations over different databases in a customer project. So that's something we have done in the past.
So the box, I need to have multiple Xpeeders?
Yes, if you want to use the off-the-box app, it's just one database, but of course you can have multiple instances. But then again, if you want to correlate data between different databases, you can either do that by yourself or we can help you. But then you have to write some code. Yeah?
In terms of like a roadmap for what you're doing, you've been mentioning a lot of like features and stuff that are customer projects.
Yeah.
Are you planning on
We have a huge, list of things we want to do, and I'm not really willing to commit exactly what kind of feature we're. Well, that is certainly one thing we are looking at. Yeah. Another thing is improved performance of aggregations, which is something we're working with right now. Because we saw that 3 times, that's great, but maybe we want it 10-ish kind of times better, and we think we're going to succeed with that goal too. Yeah. Yes?
Is Firebase functionality already released?
No, it's a customer thing. But you can do it yourself quite easily, or we can do it for you.
What was the question?
Is the aggregation supported out of the box? Any questions for John, maybe? Or Anson? Okay. Thank you, guys. Thanks for your interest.
Thank you.